All right, let's dive right into this explainer and demystify a massive headache for developers, moving your large language models out of the lab and into a rigorous production environment. We hear so much about the absolute magic of generative AI when you're just building it, right? But the reality of actually deploying it at scale, well, that is a completely different and honestly, often terrifying beast. So why do AI models just silently degrade? What's really fascinating about this question is how perfectly it highlights the stark contrast between a nice, controlled lab where everything works flawlessly and the chaotic real world where unmonitored AI can quietly, completely ruin your user experience. Think about traditional software. When something breaks, an error is thrown. A service goes down, you get a 500 error. Boom, you fix it. But GenAI, it's non-deterministic. Your model might stay completely online, handing out 200 OK statuses all day long, while silently hallucinating, leaking private data, or suddenly costing you 10 times more per token, all while your dashboard happily flashes a green light.
To fix that chaos, we are going to trace the exact chronological life cycle of an AI model. Here's our agenda for today. 1. The AI production reality. 2. Tracking your ML experiments. 3. The central model registry. 4. Conquering AI serving latency. And 5. Continuous monitoring and quality.
Kicking things off with Section 1, the AI production reality, surviving the Wild West of deployment. You've got to establish your baseline, because if you treat GenAI like classical software or even classical machine learning, you are absolutely going to get burned. Look at this comparison. Traditional ML metrics, like prediction accuracy, rely on highly structured data. It's very binary. It essentially just tells you, hey, the system is turned on. But AI monitoring, that's a whole different ballgame. You're evaluating free-form text. AI monitoring tells you if it's actually working well. Did the agent use the right tool? Did it follow the reasoning chain? Or are token costs spiraling out of control for a super simple query? You are literally having to judge the subjective quality of text, and man, that requires an entirely new toolkit.
Moving right along to Section 2, tracking your ML experiments, establishing order from chaos.
Before you even think about production, you have to actually build the thing. And building AI involves an immense amount of trial, error, and hyperparameter tuning. When you're running hundreds of tuning experiments, please do not rely on messy local spreadsheets. We've all been there, and it's a total nightmare. Leveraging public APIs from platforms like Weights and Biases essentially lets you treat your experiment history like a highly searchable database. You can pull complete data frames straight into a Jupyter Notebook for custom analysis and just sync your findings seamlessly.
So the absolute crux of it is leveraging these specific run attributes through the API to systematically organize all that chaos. Think of run.config as your architectural blueprint, your inputs, your learning rates. Then you've got run.history. These are the vital signs of your model training over time, like watching your loss curve drop step by step. And finally, run.summary holds your final scores, like ultimate accuracy. If you aren't capturing these three things systematically, you are flying completely blind.
Okay, Section 3, the Central Model Registry, your highly organized AI library. Let's see what happens when those tracked models finally graduate.
Once they're deemed successful, they go into a highly organized warehouse. And here is where model aliases become a real game changer. Using aliases inside MLflow or Databricks ensures you can update the model instantly without breaking everything else. Imagine hard-coding model version 47 into your app. You'd need a massive code update every single time you deploy. Instead, you just tell your app to route traffic to an alias, like @champion. When version 48 proves it's better, you just repoint that @champion tag to the new version. Boom! It's a seamless, absolute zero downtime handoff.
These registries give you literal superpowers for enterprise governance and compliance. Take model lineage, for example. If a model suddenly goes crazy in production, lineage lets you trace it all the way back to the exact notebook, the exact run, and the exact dataset that made it. And with cross-workspace access controls, you guarantee that only authorized folks can push a model from staging to production. It's an auditor's dream for sure.
Which brings us to the friction phase in Section 4, conquering AI serving latency, eliminating the friction.
You can have the best, most thoroughly registered model in the world, but if it's too slow, none of that matters. Imagine a user submits a prompt and faces a devastating 8-second wait time during a traffic spike. No way! They are abandoning your app entirely. This isn't just some tech metric. It's a fundamental driver of user retention. If your amazing GenAI feature feels sluggish, users don't think it's loading. They just assume it's broken.
And that brings us to time to first token, or TTFT.
This is the metric users feel the most. Even if your model spits out words incredibly fast once it gets going, if it takes 3 seconds just to wake up, it still feels broken. You absolutely have to separate this from your raw generation speed on your dashboards. If you're only looking at average total latency, you're completely missing that initial, frustrating stall that's driving your users away.
So how do we fix it? This table breaks down your pipeline tuning solutions. Continuous batching and cache-aware routing are absolutely essential here. Instead of waiting around for a fixed batch to fill up, continuous batching just processes tokens the second they're ready. And cache-aware routing is brilliant. It routes requests with similar chat histories to the same exact server. You're basically reusing the model's short-term memory, the KV cache, so you don't waste massive compute power pre-filling the same prompt all over again.
Now check out this chart. If you aren't using a page detention-based engine like VLLM, you are leaving massive performance gains on the table. Traditional methods fragment memory badly, and that pushes your tail latency, the absolute worst experiences your users have, up by over 2 times. Page detention manages memory the way your laptop's operating system does, letting you run vastly larger batch sizes and literally cutting that tail latency in half. But what about scaling from zero? If you let your infrastructure hibernate to save some cash, the next person to use it pays the ultimate price. The server has to spin up the container, load gigabytes of weights into the GPU, and initialize any fine-tuned LoRa adapters, which, by the way, can add a 300 millisecond spike just on its own. It's agonizing. This is exactly why keeping a baseline minimum of 1 replica is an absolute must for latency-sensitive apps.
And please, do not fall into this massive trap. Do not scale your infrastructure based on GPU utilization. Actually, scratch that. GPU utilization is a lagging indicator anyway. By the time it actually spikes, your queue is already backed up and your user is long gone. You have to set your auto-scaling triggers on queue depth. If the line starts growing, spin up a new server proactively before things bog down.
All right, the final stretch. Section 5, continuous monitoring and quality. Maintaining vigilance in the wild.
Deploying the model is literally just the starting line. We have to ensure it doesn't secretly drift or just hemorrhage money. With an open source stack like MLflow, you can follow these 4 actionable steps. First, trace every single request to see the exact execution graph of your agent. Second, set up automated LLM judges, other models running in the background to score those traces. Third, collect actual human feedback to calibrate those judges. And finally, track your token costs per request and enforce safety guardrails in real time.
So, I'm going to leave you with this provocative question. Are you monitoring your AI's uptime or its actual quality? Just keeping the lights on? Yeah, that doesn't cut it anymore. Don't settle for old-school metrics in a GenAI world. Build your registries, trace your requests, and scale proactively. That is how you truly tame generative AI. Thanks for diving into this explainer with me, and I'll see you in the next one.